Hi everyone, and welcome to the second workshop of this week for the ICP Bitcoin DeFi Bootcamp. So we've got a special lecture for you today, a technical deep dive with Diode and Openchat, and we have Dominic Letts and Hamish Peebles, who are co-founders of Diode and Openchat respectively. So we'll have a two-part lecture today, and that will start with Dominic from Diode, who will come up and join the stage to talk to you now. Still got me from the Encode team opening the workshops today because we are still, Rebecca is still in the Token Singapore conference. So if you're listening from there, then I hope that's going very well. Please feel free to say hi in the chat and ask questions as the lecture goes on. I think that the speakers will much appreciate if you do ask some questions so that they can get some feedback about what you're understanding as we go along. And I'll hand over to Dominic now.
Hey, thank you so much. That's great to be here. Let me try to start the share here and get some slides, and then we can get over all of that. Boom. So I hope everyone can see this, and welcome to this deep dive. Let me know if there's any questions. We're gonna have like this is gonna be like two sessions basically. So it's Hamish is gonna talk after me about Openchat. We're gonna have like 5 minutes break in between for some questions. So I'm Dominic. I'm from the Diode team. I'm CTO there. And we do what Bitcoin did for your money. We basically with Diode do that for your data and your communication. And so when people say like not your keys and not your wallet, the same is true for data very often. So if it's not your keys and not your data, what does it mean? And what is Diode doing? And what's the relationship to Bitcoin? We want to talk about that bit and then dive into the application and look a bit into how to use it and how to take full control of your communication in a self-custody way. So with that get started, let's say like what is Diode? What are we building here? Diode Collab is like a collaboration platform, like you have seen it from Discord or Microsoft Teams or Slack. So you get this, you have your friends groups, you have files, and you can share them and you can communicate with them. And the difference between like Slack or Teams or any of those is that this is a protocol rather than a platform. So if anyone is implementing the Collab protocol, they can also communicate and exchange and chat. This is very similar to email, where email does not belong to a single company, but email is a protocol, right? And so you can have one out of many email clients. And then as long as you have that email client, you can exchange emails. And contrast that to Slack, for example. Slack is owned by the company, by Slack. And so all the communication going through that system effectively ends up with Slack. Same with Microsoft Teams, same with other ways of communication. And so that's actually really a change from the old internet that we have seen, like other companies like WhatsApp, for example, are prime examples of this. Like WhatsApp is not a protocol. It is actually like a whole platform that owns all your data. It's not you owning it anymore. Or Facebook, right? You upload a picture, that picture actually belongs now to Facebook and is not something where you can plug in another app in. It's not something where you can go say, I'm going to leave Facebook, but I'm going to keep all my data. So these are platforms, but email is a protocol, Collab is a protocol, Bitcoin is a protocol, right? Which means you can actually own something there and choose different UIs or choose different clients. And this is on a technical level, but that also means on a legal level, something very different, right? So if you have a European user, for example, I'm in Germany here, and you have a European user, and I'm starting to use a Microsoft product, and then Microsoft decides to store this on their servers in the US. Now I have US law on data stored by a US company, and I have European law about what governs personal data of people. And these laws can often be in conflict. And then the companies needing to live in this conflict are these big corporations like Microsoft. So for example, there's this US law that says like the US government can look into any data on a request basis if they think that's necessary for state security, and the company cannot tell. And then on the other side, you have European law that says like foreign companies cannot look into EU citizens' data, right? So you have a conflict of law there that needs to be resolved. So for companies, that is also a big problem because it's really hard to stay in the white when all these cloud providers and all these platform providers really only offer these gray solutions where it's not clear where you are legally. You don't have this problem with protocols again, right? Because in a protocol, you can actually own the data. You can run your own email server, and then it's all your emails, and it's clear where they are. And you can still choose from 100 different clients, and you can still communicate with everyone on the planet. So we built Colab as a protocol based on blockchain technology. So anyone on the planet can use it, but you also get the same convenience that you get from cloud solutions because it's the same data all over the globe. What it's not, I mentioned that a little bit as well. So this is not, I mentioned WhatsApp, but this is not a consumer to consumer communication system. This is really for organizations. So B2B, like Slack, like Microsoft Teams that also look at companies, organizations. And the reason we do it like that is really like the self-custody aspect to it. So when you create like a self-custody realm, then you usually need to have some kind of group, right? You can have a group of like 5 or 6 people who come together and they say, we're gonna create this club, or we create this organization, we create this company, and we wanna hold all the data together, but we don't want any of the data to leave into foreign clouds, into other people's hands. It should stay under our control. And then you can say like, we have big files, we have small files, but it's all going to be shared within this group. So the weight on a per person level is not that big. You can split data, very similar to like what BitTorrent has been doing, where it's sharing data across multiple peers, but here it's always to a group. That also makes onboarding easier because it's not like when you try to get your family from, let's use WhatsApp to let's use Signal, you have to convince every single one of them, or that fails. But if it's like, if you join this company, you have to use, basically this company's communication platform is Diode, Colab, then you're just gonna install that as an employee, and you don't have to convince the world of using Union Messenger. It's just like if you're interested in that one thing that this company or group is doing. So what is a peer-to-peer protocol? So this is very similar to what BitTorrent and Bitcoin is doing, right? So everyone has this client installed that talks the Diode Colab protocol, and they can share files, they can share messages and real-time data peer-to-peer. So this is great in terms of everyone keeps their data, right? My data never leaves to somebody I don't know. So let's imagine you have medical files. Then you could imagine there's a network of doctors treating the same patient. They can share these files, but these files will never leave into a cloud storage, will never leave into Google Cloud or Azure Cloud or some cloud provider where you then have to worry, well, where's this patient's data now, in which country, under which legislation? You actually know exactly where it is. Now, that comes with some weaknesses, though, and we want to talk about that, and then we want to talk about like how we can fight these weaknesses on ICP specifically and build like better Bitcoin apps with that. So the problem of a peer-to-peer network is that there might be situations where your peers are offline, right? Especially what we're seeing with more and more people using mobile first, that they come online, they start the app, they want to send a file. So here it's Frankie wants to send a file to Loki. She presses the send button, then she closes the app again, right? So, and the moment when she pressed the send button, Loki was actually not online here. He was offline, and so she couldn't send it directly. Now, some time later on, when Loki comes online, Frankie might not be online anymore because she closed the app, right? And so I jumped here a little bit to the next slide. the way we solve this is with what we call an always-on canister. So you can basically solve this problem by saying, hey, we start up a canister that is owned by the people, and this canister is going to be our always-on fallback. So if nobody is online at the same time, it's still enough to send the file to the canister and then receive it back from someone else. So how is this different from cloud is a really important question. And this is, if you go back to the beginning, very much like your own email server. So a canister is different from a server hosted by a cloud company. So this is not, when we instantiate a canister, this canister is not run by Diode, but this canister is actually run by Frankie, right? Whoever creates that initial zone, that initial frame, that is also who's becoming the owner of the canister, right? And so in the app, you see like which canister has been created. You can interact with the canister. You can check that, hey, actually the owner of the canister is myself, right? In the same way as when you have a Bitcoin balance, you can check who's the owner of that Bitcoin balance, and you can see it's your keys. Your keys own that Bitcoin balance, and so you know it's yours. Here also, the canister is owned by you. It's not owned by a third party. It's owned by you. You have full control. It's basically your small machine there. And that's really important in terms of privacy and custody, but also in a legal sense, this is important because it means that the data has not left your control, and the data is not under somebody else's custody. It is under your custody. So this is what the canister does here. It is a self-custody mechanism to hold this data, but it's also like a machine that has a lot of capabilities, can do compute, can execute WASM code, and so it allows us to extend this and enrich it with more and more features as the Collab protocol is evolving. I'm not going to talk too much about canisters here. There's a lot more material in other talks, I think, that will cover that. But let's talk about security and encryption. So canisters are also like a concept that exists on the internet computer. And so the canister state is being shared between ICP nodes. And that brings another problem with it. What about privacy? We talked about custody, so it's very clear that only you can control it if you have the keys. Only the key owner can control it. In the same way as Bitcoin Cash, the money can only be controlled by the one holding the keys. But as with Bitcoin, somebody else can read your balance. Here also we have the problem that if we would not encrypt the data, somebody else could read the data. And that's something we definitely don't want. So all data is being encrypted that is being stored in these canisters using the Collab protocol. And it's using something from the Bitcoin ecosystem called the bit message encryption scheme. I'm not going to go much further into this, but it is a public-private key encryption mechanism. So you have a public key that you can use to encrypt anything, and then you need the private key to decrypt it. And then this way you can use a public key to encrypt it, upload it to the canister, and then Loki, in our example, can decrypt it when he has the private key. That brings a second problem, though. So we have solved this problem. We can encrypt the data. We can send it to the canister. Loki can download it. But how does Loki get the private key? Because Frankie created that private key for this data-specific private key. How does Loki get that? And this is where there's some really interesting technology that we want to talk about here for a second. And it's called vetKey. This is a technology that is available on the internet computer, and it allows you to share private keys and private key material in a way that nobody else can read it. So what's happening here is that the private key is being split into many fragments, into shards of the key. And all the nodes in the ICP network that participate in the network that you're using, they have one shard, one fragment of the key. But you need to have all the fragments to reconstruct the key. And so what's happening here is that the vetKey mechanism is using a mechanism where you basically send in a message to say, hey, restore me the key. And then each of these nodes adds their fragment to that key in a way that they can still not ever recover the whole key. So it goes around the network, it's adding their fragment to it, but the result is still encrypted. I have a small pseudo math here. This is all curve cryptography for those guys who want to go into that. And also, like, all the source code we have created here is open source. I put the links at the bottom here of the slides if you're curious about that. It's like part of the Diode protocol. So just to talk about the math real quick in like simplified terms, what's happening here is that Loki is sending like an initial key that he has, right? This is like what we call a transport public key. So he just generates it on a spot. And this is like a starting point that is already secure because it's only a pub key. It's not a private key, right? So Loki keeps like the private key to that on his own machine. But he sends out this pub key, and then the first shard is being applied to that pub key. The first shard of the private that Loki needs to know to decrypt the data. That means now this pub key plus a first shard cannot be used by the next node to extract the first shard. The next node, node number 2, it only sees the result of this combination, but it doesn't know how to turn it back into the shard and the transport pub key. Then it adds itself the second shard to it and sends it further. And again, this is not reversible. And this way, it goes around the whole node cluster, combining all the shards together, plus a transport key. And this is a result that goes back to Loki. Now he gets this encrypted key. He can now, because he got the transport private key, he can convert that encrypted key to the original key. And that's the mechanism through which it's possible to share this private key through this node cluster without any single individual of the nodes can ever see the private key. So this is the vetKeys in a box. It's something unique to the internet computer, and it allows us to do this sharing of private data without exposing any of the private details. We're really happy to do that, and I want to share a bit of the app. So I'm gonna jump here over in my other desktop. I hope you guys can see that. So this is the app. I've running actually 2 instances of this right now, just as we saw in the demo. So we have Loki and Frankie here. We have some chats. We can send the message here directly to Loki. Say, hey, what are you doing? And then we see like there's a pop in, there's like a red message, Frankie sent me something, and that's all cool. And this is now working on the peer-to-peer system, right? So this is while they're online. Now, as I said, the system is using the canister for the case somebody's offline. And we want to look at that real quick. We're going to look at the canister stats. So we see there's a canister online here. We can check out that canister. So this is on the internet computer. Canister is available here. We can check out all the stats, and it's owned by Frankie. We see it has some data. It has like 17 megabytes of data stored in it, and we can use that, for example, to upload more data. So if I'm going to go here into one of the folders, this is a directory structure that is shared between Frankie and Loki and everyone else in the team. I go in here. I am going to upload some file. This is an old file, like an open source Amiga emulator. I'm going to put this in here. And when I put a file in here, then this is going to be uploaded to the canister in multiple chunks. And so it does a parallel upload, but it also needs to chunk the upload down. So in every transaction has like a maximum size. And so there's some smart fragmenting that we do here. Now it's being fully uploaded. And that means that it becomes available on the other side to Loki here. So it's not only messages, but it's also files. And it's also persisted. So we can see here's the file that I just sent 32 seconds ago, and he gets access to that. And the whole thing is also working when one of them is offline, right? So if I go here now and I close the app, then we see Frankie doesn't have a green dot anymore. She's offline now, but I can still send her a message. Hey, are you still online? And this message is going to be uploaded to the canister. I can also do this. I see like here's the check mark just went orange, which means that it actually has been submitted to the canister and is being stored in the canister. I can also do that with files in the same way as we talked about using the vetkey encryption. But I just want to quit this as well to ensure that Loki is offline. And now while Loki is offline, we're going to start up Frankie's instance again. So let's pop that in. Just going to start this from the command line here so I can control 2 profiles. And Frankie's account is coming up. This is going to be syncing with the canisters. And indeed, we get a message from Loki, even though Loki is offline, right? And so it reached out to the canister, synced with the canister data, and got all the data back. If that made you a bit curious and you actually want to keep control of all your data, feel free to go to our website. You can download Diode Colab directly from the website for mobile, for Windows, Linux, and all the other platforms, and give us some feedback, what you like, what you dislike, and what you would like to see in order for this to compete. And if you're more curious about the internals, feel free to reach out. Also on our GitHub, that's I linked it below here, github.com Diode chain. We have the canister source code, we have the client source code, and the protocol source code, all available there for more deep dives. And that's it really from me so far. Thank you so much. And if you have some questions, I'm happy to talk about them really quick. Ooh. Yeah, Marina, you asked like who's owning the canister node? Yeah, that's a great question. So let's talk about that real quick. Because let's go to the canister here. So we see the canister is here. And so this is on the Internet Computer Network. So we see there's this canister is running on a subnet. So let's click on the subnet. And so this subnet is made out of 13 nodes, I think. Can we see them? Yes, we have the whole list of, there's 13 nodes running this. And you can check who is running these nodes. These are, as with every subnode on the Internet Computer, this is you can check it out. These are independent runners of nodes. You can basically choose the subnet you want your canister to be on. There's different subnets. There's like a European subnet. There's this one is a global subnet. There's small subnets like this one with 13 nodes, but there are also bigger ones like with 26 nodes. And so it's pretty much ensured that none of these subnets is controlled by a single entity. They're all decentralized subnets. And you can also become a node runner yourself on the Internet Computer. And because it's a third party, as I mentioned, all of this data that is being sent there is actually encrypted. I hope that answers the question. Yeah, what license? Yeah, just check it out. I mean, I can. If you go to like you can see the contracts, or you can check out the client implementations. Most of that is, I think, all of that is an Apache license, and you can check it out. Okay, I'm just going to stop sharing, and then over to you, Hamish. Yeah, it would definitely be fun to merge this with an AI agent. Yeah, there's actually some things we do there. But...
Hello. Yeah, thanks for having me, everyone. I am Hamish. I founded a thing called Openchat, which I'll share screen and go into the details. So here we go. Go back to the beginning. So yeah, I am one of the co-founders of Openchat. We started building it a few years ago when the internet computer launched. I can't actually tell if this is, can you, I guess it's working. I'll just assume it's working. And yeah, Openchat is I'll go through the slides. So in this talk, I'm going to go through how Openchat makes Bitcoin fast, cheap, and easy, which is what everyone wants. So first of all, what is Openchat? It is a messaging app, much like Signal, WhatsApp, but it's running on the internet computer, and to date we have 220 odd thousand users. It is free, but then there's like premium membership available for people who want a few added features. Messages take roughly 2 seconds to arrive, which you don't really notice if you receive a message from someone 2 seconds later, because it's all happening asynchronously. And crucially for this talk, you can send cryptocurrency within messages. So let's go into some details about Bitcoin. So Bitcoin, if you send it to someone, they will only receive it about an hour later. And that's because the block speed, there's one block every 10 minutes, and normally most services require 6 confirmations, so 1 hour. And that transaction will have cost you $1, and the max throughput is only 7 transactions a second. So, leaves a lot to be desired, those stats. And so in comes a thing called ckBTC. Now, this is Dfinity, who build the internet computer. They came up with ckBTC, and it's essentially, it's very much like a wrapped Bitcoin. It's one-to-one backed by real Bitcoin on the Bitcoin mainnet, but it doesn't involve any it doesn't involve any like parties holding the keys. It's all done using threshold cryptography, the same cryptography that they use to secure the internet computer network itself. So it's all nice and secure. And it has much better properties than Bitcoin in terms of the speed. So it only takes roughly 2 seconds per transaction, costs roughly 1 cent, and you can get in excess of 500 transactions per second. So basically, we want to be using this rather than this, but everyone knows Bitcoin. I'm sure everyone here has, over their time, bought a little slice of Bitcoin. If you've bought loads, then well done to you. So yeah, what is ckBTC? So it stands for Chain Key Bitcoin. So chain key is a term that Dfinity have introduced to describe their threshold cryptography. So it runs on the internet computer. It's backed one-to-one by Bitcoin, and crucially, you can easily swap Bitcoin to ckBTC, and vice versa. You can go back from ckBTC to Bitcoin. And yeah, it's got no centralized bridge, which normally, so when there are lots of implementations of wrapped Bitcoin, and they almost always involve maybe a pool of 5 people who each hold keys, and they might need to do like a 3 or 5 signature to access the funds. In this case, there's no individuals who hold the keys. There's the Bitcoin key is basically split between a subnet where I think there are 34 nodes, and that will increase over time. And basically, as was shown in the previous talk, the subnet is able to sign using threshold signatures so that no one node ever knows the full key. And you can check out more details here. So internetcomputer.org/ckBTC. So the way to get ckBTC, the way to convert Bitcoin into ckBitcoin, is you go via the ckBTC minter. And so this handles everything for you. So as an end user, it's nice and simple. you can just get your deposit address by calling getBTC address. Once you've done a deposit, you can then update your ckBTC balance, because you need to currently, anyway, I'll describe a bit later an improvement that's coming, but currently you have to tell the ckBTC minter when you've done a deposit, and it will then go and check your balance and it will say, yep, I've seen your deposit, here is your ckBTC. And then you can convert back from ckBTC into Bitcoin by calling the retrieve BTC endpoint. And here you would pass in a Bitcoin address to withdraw to. So yeah, if you're building a service and you want to support users being able to send deposit Bitcoin and then send under the hood ckBTC, you don't want them to have to manually call update balance. You want to automate this. So what we do in Openchat is everyone who has generated a Bitcoin deposit address, every minute we send a query, like a quick request to this endpoint on what's called the Bitcoin canister. And the Bitcoin canister, again, it's running on the internet computer, and it pulls in all of the history of the entire blockchain for Bitcoin. And so you can query this endpoint to get the list of UTXOs, that's the unspent transaction outputs. And basically every time you would do a deposit to your address, there would be a new UTXO or multiple in some cases. If there are any of these, then what you do is you query the ckBTC minter to ask it, get known UTXOs. And then if there are any UTXOs that the Bitcoin canister tells you about that the ckBTC minter doesn't know about, only then do you need to call update balance. And so within Openchat, what we do is every minute we'll query these endpoints, and if we detect new deposits, we will then query update balance. So from a user's perspective, they just deposit Bitcoin, and behind the scenes, the ckBTC will just appear in their wallet. So yeah, within Openchat, you can open up the wallet. I'll show all this later. I'll do a demo. But within Openchat, you can open up your wallet, and then it gives you the option to either deposit Bitcoin from the Bitcoin mainnet or ckBTC. And then if you deposit Bitcoin, then it's automatically converted into ckBTC. And once that has been done, you can then send it to other users. It will only take a few seconds. It costs 1 cent. And normally when you send Bitcoin, you have to input a really long, completely, like the addresses are meaningless to humans. Whereas if you if you send via Openchat, you just send it to a username. So you'd say, send it to @whoever. And then you can withdraw it back at any time. And all this conversion happens invisibly. So within Openchat, we don't actually mention ckBTC. We just label it as BTC. So yeah, this is just an image of how the deposit Bitcoin page looks. You can pick to either use the Bitcoin network or the ckBTC. And you see there's like a little fee. That's not an Openchat applied fee. That is the fee applied by the Bitcoin network. So yeah, let's do a quick demo. So this is let's close that. This is the test version of Openchat. It is actually running on the internet computer mainnet, but it's just what we use for testing things before we deploy stuff to the main version. You can see my riveting conversation with one of the other co-founders. So if you open up the wallet, you'll see here, luckily I deposited this Bitcoin about an hour ago, and luckily it's made it here in time. So what you can do is you can click on receive, and you see you can have your ckBTC address, or you can have your Bitcoin address. And regardless of which network you use, under the hood, it will always get converted into ckBTC, but Openchat then just surfaces that as Bitcoin, because from a user's perspective, you don't need to know that it's ckBTC, because it's one-to-one matched, one-to-one matched with Bitcoin on the Bitcoin mainnet. And so now I can say to Matt, I can send him a bit of Bitcoin. How many zeros do I need to put here? That'll do. Test. So now I just click send. Yeah. So this. Oh, come on. Okay. That's a bit slower than usual, but it's still a lot quicker than the 1 hour you'd have to wait if you were sending a Bitcoin transaction on the mainnet. And so now Matt has got his ckBTC, but for all intents and purposes, that is actual Bitcoin, because you can come into the wallet and you can, again, when you're withdrawing, you can choose which network you want to withdraw it to. And if you withdraw to the Bitcoin network, then you just enter a Bitcoin address, and under the hood, it will convert that into Bitcoin. And so basically, this is now allowing you to send Bitcoin around in a few seconds for 1 cent, no having to input big, long, garbled addresses. You just pick who you're sending it to, click send, a few seconds later, all done. And so, yeah, that is how Openchat makes use of the Bitcoin integration to make Bitcoin fast and cheap and easy. And yeah, that's the end of the slides. There is one thing that I didn't actually put in the slides, but I wanted to cover. I was saying that when you've done a deposit, you then have to call update balance. I submitted like a idea to Dfinity of how we can remove the need for that, so that you can just do the deposit and everything from then would be automated. And so I think that idea is going to be accepted. So, in the not too distant future, you could, if you wanted to build something running on the internet computer that allows users to do the really quick and easy Bitcoin like we do in Openchat, you wouldn't actually need to do the manual step where you're querying for deposits, and then when there's a deposit, you'd call update balance. All of that would be handled for you, which is just a nice, just a nicer developer experience. But yeah, that's it. That's all I wanted to cover. And yeah, if you have any questions, feel free to drop them in the chat. Yeah. Thank you, Adam.
Doesn't look like there are any questions that are coming. You must have been so clear in your presentation. But yeah, thank you both Hamish and Dominic for showcasing both your techs and explaining how they work. That's really nice to see. And I hope you all watching enjoyed it, and for those of you catching up asynchronously as well. So yeah, I think we'll end the workshop there, unless Sam, who's typing, has a question. Yeah, I think, okay, yeah, there we go. Thank you. Yeah, okay, we'll end it there. Thank you very much, guys. As always, you can catch up and watch these workshops through the program. And if you have any questions, please reach out through the Discord and get in touch. Yeah, thanks again, guys. And we'll see you soon.
Thank you. Bye.